What are submerged shells? Now you would think that this is a question of probably social science. So there are some shells and mortars, some of those things which got submerged in the sea during wars, and that is what we are talking about. But that is not indeed the case, believe me. So this is a question of periodic table. Okay, so what are submerged shells? See, submerged shells have become very, very important recently because of lot of applications of the transition metals that we are seeing. Okay, so in the case of transition metal, that's the hint, we see these submerged shells. So now if you have guessed the answer, put it in the comment section below, and I would surely appreciate it. What are submerged shells? So let's look at this, our periodic table. So this is our S block and here is our P block. In the case of S block, let's what we find is that the last period, the last shells which are getting filled up, right? The shell which is actually filling up is in the last shell. So for example, in the case of let's take the fourth period. In the case of potassium, where is the electron getting filled up? It is getting filled up in the 4s subshell, and this of course 4 is the last shell where the electrons are getting filled up. Okay, so that is what it means, right? For S and P, this is always true. In the fourth period, S block, it is the 4s is the where the electrons are getting filled up, and 4 is the last shell. Similarly, for here from gallium to krypton, where is the last electrons? Where are they coming up? The next electrons, where are they coming up? Which shell is getting filled? It is the 4p. So 4 is actually the last shell. It is the highest quantum number shell in that particular element, and that is the shell which is getting filled up. Okay, so we are not talking about that. Those are not submerged shell. Those are the outermost shells, if you will. In the case of D block elements, in the case of transition metals, what happens in the case of transition metals? It is the one lower shell which is getting filled up. So for example, in scandium, what is the configuration? Its configuration is argon and then on top of calcium. So from calcium we get these two electrons, 4s electrons. The scandium, the next electrons comes in 3d, right? So highest quantum number is what? 4, but we are filling electrons in quantum number 3 in the shell with quantum number 3, principal quantum number 3, the third shell. So in the case of D block, it is the submerged shell which is getting filled up. So it is the one lower than the outermost shell which is getting filled up in the case of D block. In the case of F block, right? So these F block, also known as inner transition elements, the F block, it is two lower quantum number shell which is actually getting filled up. So those are also submerged shells, and recently a lot of research is being done on these submerged shells and the chemistry and the quantum chemistry in some ways of the submerged shell, that how do those electrons even interact if they are not in the outermost shell. These inner electrons in the submerged shells, how do they even react? How do they come into picture? How do they form bonds? Okay, and those things have become very, very important of late because of the importance of their compounds of the D block and the F block elements, and that is why a lot of research is being done in this area of submerged shells and their quantum chemistry. How do they react in the first place? Okay, so again, submerged shell are those shells which are important for bonding but are not in the outermost shell of that particular element. It is not the highest principal quantum number shell electrons. Okay, so those electrons, if they participate in bonding, we say that those are the submerged shell electrons which are participating in the bonding, and they become important for the D block and F block. Okay, hopefully things are clear. Thank you very much.